All right, hey guys. So you've got again, you have your exit card tomorrow, and I was going to go through. I already did page 126. It's already up. I'm going to do 134 first because I think that's the one that most people might need help with, and then I'll backtrack to 131 and 129. I'll get all of them up tonight, but I wanted to start with 134. So let's do it. So here's 134. Um, this is where we have to actually use trig to solve. And there's definitely questions like this on the assessment. Um, so I don't know. Let me do this first one with a lot of detail so you know what the steps are. So I'm going to cover this problem, make some room real fast. The steps for solving for x in a problem like this. Your first step is to label the sides that you have. And let me make this bigger too. Okay, so anyway, to solve for x, we're obviously going to want to use the 28-degree angle. So if we take a look at that angle, then the x is opposite from that angle, and the 19 is the hypotenuse since it's opposite from the right angle. And that means that down here, all alone and blank and empty, this is the adjacent side. So once everything's labeled, you need to figure out whether this problem is involving sine or cosine or tangent. And of course, we're going to fall back on SOHCAHTOA to remind us which function is which. So we know that sine is opposite over hypotenuse. Sine equals opposite over hypotenuse. We know that cosine equals adjacent over hypotenuse. We know that tangent equals opposite over adjacent. That's what SOHCAHTOA means. I was a little shocked to hear that some people didn't actually know what SOHCAHTOA even stood for, but that's what it stands for. It's to help you to remember which sides to use in each trigonometric fraction. All right, let's think. We want to solve for x, and x is opposite. We want to use the 19, and 19 is the hypotenuse. So which of these trig functions has opposite and hypotenuse in it? Well, it's sine. Sine is the one that has opposite and hypotenuse in it. So to solve this problem, we need to write a sine equation. Now, another way to think about this is the one side we don't have, right? It's not a variable, it's not a number, it's just blank, is adjacent. So looking through, cosine has an a in it. We can't use cosine because we don't have the adjacent side. And TOA, tangent, has an a in it too, so we can't use tangent either. And then the only thing left is sine. So I don't care how you figure out which trig function to use, but make sure you understand how to know which trig function to use. And we need to use sine. That's a fact. So now, once you know that we're using sine instead of anything else, you'll write your equation, and you'll always write the equation in the form sine of an angle. The angle measure goes inside the parentheses, and then it equals a fraction, where on top you're putting a side, and on the bottom you're putting a side. And of course, for sine, those sides are the opposite and the hypotenuse. So it sounds like the equation that we should write if we're trying to solve for x would be one where the sine of our 28-degree angle would be equal to x over 19. All right, so now that the equation's written, I like to just chuck this over 1 and then cross multiply. So we go 1 times x, and that gives us 1 over here on the left-hand side. Then we get 19 times the sine of 28. And then that's kind of it. From there we can just solve. Let me see if I can pull up my calculator. Yeah, I didn't think so. All right, let me pull that up again. I think my calculator kind of crashed. Any minute now. There it is. Okay, there it is. All right, so I think you're seeing it on your screen now. It's kind of like in the way and stuff. So let me move it over. Put it there. All right, so again, if you have one of these more expensive graphing calculators, then you can type in exactly the way this looks. You can type in 19 times the sine of 28. Just hit sine 28. And you'll just get the answer straight away. Well, I'm not getting the answer actually. You got to be careful. This answer is wrong because my calculator is in the wrong mode. So if you do have a calculator like this, before you do any math, click this button right here that says mode and make sure that you're not in radian mode. Radian mode is bad. You're going to want to hit the down arrow, down, down, and then over to degree and hit enter. And make sure that the degree turns black and the radian turns back to white. We need to be in degree mode because if I now go back, if I redo 19 times the sine of 28, then I'm going to get a different answer because degrees are totally different from radians. It's like if I told you that the temperature outside was 50 degrees Fahrenheit versus 50 degrees Celsius. Those are very different temperatures. Or if I told you that I was 3 meters tall versus 3 feet tall, that's kind of different, right? So trying to take the sine of 28 degrees is just a completely different thing from the sine of 28 radians. It's a completely different kind of measurement. So anyway, we now see that our correct answer is actually 8.91995. So let's round that off correctly. If we're getting, well, what have I done? I wrote 1 when I was supposed to write x. But x is going to be 8.91995. Is that what I said? I already forget. And I closed my calculator by accident. Let me bring it back. Anyway, we're going to round to 2 decimal places. So if it is like this, then we would get 8.92. But I don't think it is like this. Hold on, we're going to try this again. Okay, there's my calculator again. Oh, I was right. All right, it is 91995. So great. That means if we're rounding to 2 decimal places, then whatever number is in the third spot, that's the only one you worry about. And as long as it's bigger than 5, if it's 5 or bigger, I should say, then this number will round up. So instead of 91, it goes to 92. So x will be 8.92. And that's it. That's one problem down. Let's do more. Let's do a lot more. Okay, so I think what I want to do is duplicate this whole page. That way I can still go back to it. Then I'm going to clear everything off of it. And we can try number 2. Throw this guy in the trash. And we'll try number 2. And again, I'll make it a little bit bigger. So again, our first step was to label the sides as opposite adjacent hypotenuse. That looks a little bit better. And looking at this problem, we can see that we want to use the 41. The x is opposite from it. The hypotenuse is down here. And notice the hypotenuse is the guy that we do not have. This 32 is adjacent then. So that means given the choice of sine or cosine or tangent, again, you got 2 ways to think about it. We want the one that has O and A in it. We need O and A, so that would give us tangent. The other way to think about it is we do not want the one that has hypotenuse in it. So that means sine is out because it has an H. Cosine is out because it has an H. We have to write a tangent equation. So our tangent equation will be the tangent of 41, and it equals x over 32. Again, once your equation's written, just put this over 1 so you can kind of cross multiply easily, and you'll get x times 1 is x. Our final answer is going to be whatever 32 times the tangent of 41 is. And I'm realizing just now that I forgot to actually explain how to find the tangent of 41 when you don't have one of those fancy calculators. So we want 32, then we want to multiply it by whatever tangent of 41 is. Well, tangent of 41 is just going to be some big long decimal. And without a calculator, the only way to find it is to use our little table of trig values. So here's a table. Let me get the calculator out of the way by doing what? How do I get rid of it? Just do that, I think. Yep. All right, so it's out of the way. Now this table isn't so big, I'm not sure if you can read this super well, but we want the tangent of 41. So the first thing you do is you look in this first column for a 41-degree angle. So just scroll down, down, down. There it is. There's 41. But again, you got three choices. There's sine, cosine, tangent. So since we're doing tangent, make sure you focus your eyeballs on the third column. And there's your 0.8693. That's your tangent. So just grab that number from the sheet that I gave you and pull that over and put it down on your homework. It's 0.8693. So that's going to go in parentheses for us. So it's technically 0.8693. And so now, even if I had a calculator that doesn't know how to do trig, I can still find my answer because, let me bring the calculator back now. I can just type in the decimal from the worksheet. So I can type in the 32 multiplied by 0.8693, and if I multiply by 8693, I get a final answer of 27.8176. So 278176. X equals 27. Oh, I'm so bad at remembering these. 8176. Okay, and on your quiz I want you rounding to two decimal places. So again, imagine if we were rounding here, then it's either going to be 27.81 or 27.82, and it just depends on who you're closer to. And if I have a 7, that's past the 5, so I'm closer to 82 than I am to 81. So we are going to round this up, and you'll give me a final answer of x equals 27.82. And that's it. So there is a big thing I'd have to definitely mention now. There are some problems where the x is in the denominator, and some kids in class struggled with that. So let me find one of those, we'll do it. There's my dog. He always shows up. There he is. Okay, anyway, back to work. Let's make sure we know how to do that type of problem too, and I'm going to go through these much faster now. But let's take a look at 3. 3 is not the kind of problem I was talking about. Neither is 4. I'm going to jump ahead a bit and find one. 5. 5 is the kind of problem I was talking about. So let's work on 5 real fast, and then that way if you guys feel like you know what you're doing, then we'll have all our bases covered and you don't need to watch anymore, honestly. If you feel like you understand 1 and 2 and also 5, then you know your bases are covered. Okay, so I'm going to make this guy a little bigger again. And we're going to do all the same steps as before. We're going to take the given angle, which is 33. 15 is opposite from it. X is the hypotenuse. And so that means if I have opposite and hypotenuse, then in SOHCAHTOA, we see this is another example of a sine problem because we're using opposite and hypotenuse. So the only difference now is when we write our equation, we'll do sine of 33. But this time, when we write our fraction, the number that we have goes in the numerator, and the variable goes in the denominator. If you look back to the previous problems, the variable was in the denominator, in the numerator, I should say. For number 2, the variable was in the numerator. For number 1, the variable was in the numerator. That makes the math a little bit easier. So number 5 is going to have a tiny twist to it. And it's no big deal. It's just algebra. But the algebra would say here that I cross multiply, and I get 1 times 15, so that's 15. But then when I cross multiply, I get x times whatever the heck the sine of 33 is. So I'm not really done. Like x is not alone like it was in numbers 1 and 2. X was just alone after we cross multiplied and we didn't have to do much more. But I still have a step of algebra. If you want to get x alone and x is being multiplied, well, the opposite of multiplying is dividing, right? And if the thing that you're trying to get rid of is sine 33, then you better divide by the sine of 33. And of course, whatever you do to the right, you must do to the left. So over here, I also divide by the sine of 33. And just like anything else, when you divide a number by itself, it cancels out. And so that means now that the only thing left over here on the right is x. And over here on the left, we have 15 divided by the sine of 33. And again, sine of 33 is just a number. So I would go to my little conversion chart, and I'm looking for the 33-degree angle. So I better go up, up, up. There's 33. And then I'm looking for the sine of that. So I scroll over to sine, and it's 0.5446. So if I bring that number over, then we can see that our answer is going to be whatever 15 divided by 0.5446 is. And now's as good a time as any to go to your calculator and just type that in. I'm curious about what 15 divided by 0.5446 is. And if you hit enter, you'll get your answer. It's 27.543. 27.5431. All right, again, one more time. You guys should be rounding all your answers down to 2 decimal places. So that means you're either going to give me 27.54 or round it up to 27.55. But this time my next number is 3. That means I'm closer to 54 than I am to 55. So instead of rounding up, we'll round it down and you'll give me the 54. So x equals 27.54. That would be the final answer. But that's it. That's the only 2 ways that these kinds of problems can go. You're either going to have 15 over x or you're going to have x over 15. And the algebra feels a little different depending on whether x is in the numerator or the denominator. But you've seen examples of both now. So if you guys are feeling good about this, you could, obviously you could just go do more practice problems in the Delta Math, or you can keep following along with me and I'll do the rest of the homeworks. So we're dropping back to 3 real quick. And in number 3, I make this a little bigger. Sure. All right. I would label the parts if I were you. So here's the 21. Opposite from 21. Well, that's blank this time. The 26 is our hypotenuse. And this guy is adjacent. That means I'm operating with the adjacent and the hypotenuse. And so again, in SOHCAHTOA, you could think about, well, who doesn't use the opposite side? Sine does use it, cross that out. Tangent uses the opposite side, cross that out. We can see that this problem is a cosine problem, which makes sense because in this problem we do have a as our variable. We do have h as our known side, that's 26. So we need to write a cosine. So we'll do the cosine of the angle they gave us, which is 21. We'll set it equal to the fraction that has adjacent on top and 26 on the bottom. And from doing a few of these problems already, you know that we're just going to put this over 1 and cross multiply. You can see that we're just going to get x times 1 as x. And our final answer is going to be whatever 26 times the cosine of 21 is. So x will be approximately, let's go find cosine of 21. That's over here. All right, so 21 is going to be up, up, up a bit. Here's 21 right at the top of this. And cosine is the middle column, so pull this middle number. I'm seeing 0.9336. So I'm going to do 26 times 0.9336. And that's going to come out to whatever it comes out to, 26 times 0.9336. 24.27. That's it. So that's number 3. We can do 4 now. We move the calculator over. We'll tackle 4. Okay, exact same approach. Nothing's going to change. We're still going to label our sides. And across from 8, I'm seeing an opposite side. Oh, geez, what am I doing? Excuse me. across from the 55, we see the opposite side is x, and 8 is adjacent. So if we're working with O and A, then this time we do want TOA. So for number 4, we're going to write a tangent equation that has 55 in parentheses, and it equals the x in the numerator and the 8 in the denominator. So that means we'll cross multiply, and we'll get 1 times x is equal to 8 times the tangent of 55. So that means x is approximately 8 times whatever the tangent of 55 is. Let's go find that. In our chart, 55 is pretty big. The bottom over here ends at 45. So go over to the other column and find 55. It's here at the bottom of this group. And we're doing tangent again, right? So it's 1.4281. 1.4281. So in it goes, 1.4281. That means that x is approximately 8 times 1.4281. Hit the buttons, get an answer, 11.4248. And again, we're going to round to just 2 decimal places. And this 4 is not high enough to round us up to 43, so we're going to stay at 42. So your final answer is 11.42. That's it for 4. And we already did 5, so we can move on and do 6. So here's 6. I'm going to make it a little bigger. Keep it on this side of the calculator. I'm going to start going even faster, I think, because I think you guys have had enough examples, but opposite from the 43 is blank. Adjacent to the 43, though, is this 36. And then this x is our hypotenuse. So this is another problem where we want to use the a and the h. So that means we're not using sine, we're going to use cosine, because cosine is the ka in SOHCAHTOA. If we want a and h, then we want cosine. So write me an equation. Cosine of 43 is equal to adjacent over hypotenuse, so 36 over x. And we see that this is now another example where the x is in the denominator. So the algebra plays out a little bit differently. When I cross multiply, I don't get 1 times x, I get 1 times 36. So we get a 36 over here on the left. And then we get x times the cosine of 43. That means we have that one more step where if you are trying to get x alone, then you have to divide both sides by the cosine of 43. Those will cancel. And we'll find that x is going to be equal to whatever 36 divided by the cosine of 43 is. And to evaluate that, we need to use our table to find the cosine of 43, which is going to put us back on this side of the chart right here. Yeah, you guys can see that. And the cosine is the middle column. So 7314. So the cosine of 43 is 0.7314, and we're dividing 36 by that number. And it's kind of weird. You might have noticed in the previous one, but when you divide a number, normally division makes things get smaller, but when you divide a number by a decimal like this that's less than 1, the number will actually get bigger. So if you get an answer here that's bigger than 36, that's normal. That's supposed to happen. So let's see what we get when we do 36 divided by blah, blah, blah. 36 divided by 0.7314. It gives us 49.22. Well, that's it. So that's number 6. We can go do 7. So how many more are there? 7 and 8, 9, 10. And then it kind of starts over again with just some more questions about writing ratios, which is good. That's good practice because that stuff's on the quiz too. So then there's 1 and 2, 3. Oh, there's a lot. I do not want to do all these, but if I'm asking you guys to do them, then I'll do them too. I may just start going a little bit faster because I don't think anybody wants to watch a video that's 30 minutes long anyway. Okay, so we're on 7. All right, move the calculator over. And to do this problem, I again see opposite and I see adjacent. So this is a tangent one. Tangent of 72 equals 25 over x. So if I cross multiply, I get 25 equals x times the tangent of 72. So that means to get x alone, you got to divide both sides by the tangent of 72. And that's going to give you an x that equals 25 divided by the tangent of 72, which means we get 25 divided by, let's go find the tangent of 72. Calculator is in the way big time. Move that over. All right, 72 of course is right here, and the tangent is 3.0777. And so obviously dividing 25 by 3 is going to make this actually get smaller. So I'm definitely expecting an answer that's less than 25. Let's go see what that answer is. 25 divided by 3.0777. 8.122. So if I round off correctly, it's 8.12. That's another one down. Let's do number 8. Okay, for 8, the opposite side is blank, which means we're going to want to be working with the adjacent side and the hypotenuse. That sounds a lot like ka from SOHCAHTOA. So this is a cosine one. We want to do the cosine of 64. And we want to set it equal to the adjacent over the hypotenuse, which is x over 11. Which means this is one of the easy ones, algebraically. We cross multiply and we just get x equals 11 times the cosine of 64. So that means x equals 11 times whatever the cosine of 64 is. Let's go find out. 64 is up the chart just a little bit right here. Cosine's in the middle. So 43/84. And if you multiply, you'll get an answer. So let's go do that. So it's 11 times 0.4384. So 4.82. Okay. This is getting a little repetitive, even for me. I think if you're still tuned in, you probably have a good idea how this stuff works. So tell you what I'm going to do. I'm going to write out the answers, and then I'll just show them to you all really quickly, until we get to something different at least. Okay, this assignment is entirely too long, but I just did a bunch. So we just did 7 and 8. 9, 10, 1 and 2, or 1 at least. I'm going to come back to those, But in this next bank of problems, if you guys wanted to do these for practice, here's the answers. Just click pause and you can look these over. But here's the answers to 2 and 3, and 4 and 5, and 6 and 7, and 8 and 9, and 10 and 11, and here's 12. So 12 is a little different. So if anybody is sticking around, I can go through 12 and 13 and one more word problem, another one, but that'll get us up to 136. So let me go back to the other word problems that I skipped over. And if anyone is sticking around to hear about how the word problems work, I'll go through them. There's no word problem on the exit card though, I can tell you that. There isn't one. So if you're sticking around because you're nervous about that, you don't need to be nervous about that. But let's do a couple at least anyway. It says Jake leaned a 12-foot ladder against his house. So, you know, you don't have to like draw a real house or nothing, but I'm gonna draw a house. Hey look, it's a house. It's even got a chimney, smoke coming out of it. But he leans a ladder against it. So the ladder maybe reaches up this high and comes down the side. It says the angle formed by the ladder and the ground is 68. So if this is the ground, then this angle right here is 68. It says how far from the base of the house did he place the ladder? So you're looking to solve for this distance along the ground. And they told you the ladder was 12 feet. So that means the hypotenuse is 12. Once you read and understand the words and make a drawing, it's not that tough anymore. It's exactly like all the other problems now. So you can see that in this problem, opposite side is the house, the adjacent side is x, and the ladder itself is the hypotenuse. So since we're working with adjacent and hypotenuse, this would be a cosine problem. Cosine of 68 would equal the x over 12. So if you've really been paying attention to all these practice problems, you know that at this point, we're really just multiplying by 12. And we can see that 12 times the cosine of 68 is going to give us our answer. That's going to be our x, or our distance. So 12 times the cosine of 68, that's coming out to 4.495. And so just to remind you guys how to round that off, if we're going to two places, remember your options are that we're either going to keep this 49 as a 49 or we're going to round it up to 50. And since we're at 5, we are going to round up. So technically the 5 rounds the 9 up to a 10, but then you kind of carry the 1 over and the 4 goes up as well. So you end up with 50, which makes sense that the 49 would go up to 50. So when we round this off, we're getting 4.50. And since the ladder is referred to as being in feet, our answer is in feet. And that's it. Let's see the next one. It says a ramp is used to load suitcases on an airplane. The cargo door is 7 feet from the ground. So there's like this airplane and stuff. Wing. Window. That's pretty good airplane. But anyway, they got to load stuff into the back of the airplane. And the airplane is up on these really tall wheels. So the ground is way down here. So that means to get up and load stuff into the airplane, they need a ramp. There's your ramp. And guess what shape the ramp is? It's a right triangle. So let's pull out the information they gave us. They said that the cargo door is 7 feet from the ground. I assume they mean straight up. So 7 is this vertical distance here, straight up and down. And it says the angle formed by the end of the ramp and the ground is 25. So this angle right here is 25 degrees. And you're being asked to find the length of the ramp. So this distance here, let's just call it x. You're looking to solve for that. So, okay, great. We drew a picture. Now the rest should be a piece of cake because here's our angle. 7 is opposite. X is the hypotenuse. So we would just write a sine equation. We'll do sine of 25. Set it equal to 7 over x. So this is that trickier situation where if I put this over 1, then 7 times 1 gives us a 7. That equals x times the sine of 25. So we haven't actually solved for x until we divide both sides by the sine of 25. So we're going to get an x that equals 7 divided by the sine of 25, which my calculator tells me is 16.56. And again, what are my units? Is this inches or pounds? What is it? Well, it's feet. It's feet again because it says so. So put feet on your answer. And that's it. That's 2 word problems. And then real fast, we'll just bang this out. So, because there are questions like this. But it says find the sine of q. Well, sine of q is just a fraction. So you find angle q. And sine is opposite over hypotenuse. So, well, be careful. Because it's not 14 over 50. Because you have to reduce that. And 14 and 50 are both divisible by 2. So if I divide by 2, I get 7. And if I divide by 2, I get 25. So the actual final answer is 7 over 25. Okay. Then if you try to do cosine, we get a bit of a problem because cosine would be adjacent over hypotenuse. So I'm fine with the denominator. Denominator is going to be 50 again. But what's this adjacent side? We don't know. So you guys have to do Pythagorean theorem to solve. So you'd have to do 14 squared plus x squared equals 50 squared, which means 196 squared plus x squared equals 2500. And then to get x alone, you'll subtract 196 from both. Oops. I should not have written 196 squared. It's just plain old 196. And we're going to subtract 196 from both sides. So that cancels, and I now have an x squared that equals, what am I doing? Taking away 200, so 2304. And I got a good idea that I think this comes out to be exact. So if we, in our calculators right here, if we do the square root, so you go second square root, and we plug in 2304, I think we're going to get, what are we going to get? 48. Nailed it. So it's 48 exactly. I know most of the time radicals come out to be decimals, but they don't always. Sometimes they do come out to be perfect. So we're getting 48 as that missing adjacent side. And now that we know that that missing side is 48, we can use it to solve all these other trig ratios. So that means cosine of q is going to be the 48 over 50. But again, remember, you cannot leave your answer like that. You have to reduce. So chop them both in half, and you get 24 over 25. That's your answer. For the tangent of q, you want opposite over adjacent, so that would be 14 over 48. But that also reduces to 7 over 24. And then something a lot of people figured out is when they switch angles and they go from Q to R, the cosine becomes the sine. You know it's going to be 24 25ths. That's kind of the rule. That's the relationship. So then the 7 25ths that used to be sine becomes the cosine. You know that's going to happen. You don't even really need to think about it. And then what happens with the tangent? Well, the tangent becomes the reciprocal of what it used to be. So the 7 goes to the bottom and the 24 comes to the top. And that also will happen every single time. Okay? So what happens? The sine becomes the cosine becomes the sine, and then the tangent flips upside down. And that's it. I'm not doing any more. This video is already 40 minutes long. So you've got all these. I told you can just pause the video if you want to look these over. After these comes a couple more problems that are much harder than I would put on the quiz, so I'm not even going to spend the time on them. And then a few more word problems that are also not on the quiz, so I don't care. You might want me to come back and talk about these when it comes time to take our bigger 25-point assessment. But tonight, don't worry about it. I just want to get this video published. So, good night. See you later.